Hi everyone, this is Unit 11, Lesson 4, the unit circle. So this is a huge part of what we're going to do, focusing on for the rest of this unit. So the unit circle is a circle centered at the origin with a radius of 1. So you can see my circle right there. The center is the origin, and I have a radius in 1, so I'm going 1 in each direction. The equation of that circle is x squared plus y squared equals 1. So in exercise 1, we're going to have a line segment. It's constructed from the origin, intersecting the circle at x, y. So this line that I'm drawing right here in purple, okay, it intersects the circle right there at x, comma, y. Now we know the length of this is 1, all right, because the radius of my circle is 1. So it's in quadrant 1, as shown. The line segment makes an angle of theta with the positive x-axis. So I'm going to drop this line straight down, okay, making a triangle. And this angle right here is theta. Now let's label the vertical and the horizontal line of that triangle. So the distance from the x-axis to that point, it has a height of y, and the distance from the origin to where that triangle is has a length of x. Okay, so that's how you label the sides of the triangle. The left-right is your x, and your up-down is your y. And this works because I have a radius of 1 that's going on. All right, so now I want to find sine, cosine, and tangent of theta based on how I've labeled this triangle. And this is a right triangle that I have. All right, so my sine of theta, sine is opposite over hypotenuse. So it's going to be y over 1. So sine is y. The cosine of theta is adjacent over hypotenuse. So that's going to be x over 1, which is x. And tangent of theta is opposite over adjacent. So the opposite is y and the adjacent is x. All right. So xy, this is important. xy, the x, look right here. My x is my cosine of theta. And my y is my sine of theta. So xy is really, I'm going to put some stars here, xy is cosine of theta, comma, sine of theta. All right? Cosine of theta was equivalent to x, and sine of theta was equivalent to y. So this is important. I've got a little star there. And tangent of theta is sine over cosine. Because remember, tangent of theta, look right here, tangent of theta is y over x, and y is sine, and x is cosine. So this is another important thing to remember. All right, so sine of 90, okay, sine of 90 degrees equals 1. Sine of 90 degrees equals 1, because look right here. This is 90 degrees. If I'm looking at 90 degrees, let me, I don't know, circle it in red. Okay? This is 90. If I was to, this, right, is 90 degrees. And sine is equal to the y, so sine of 90 is 1. The cosine of 360. Well, 360 starts here. I'm always going to start here, and I'm going to go all the way around. So if I go all the way around, let me get a highlighter. If I start here and go all the way around, I'm going to wind up back at the beginning again. And cosine is my x, so cosine of 360 is 1. Cosine of 180. Well, 180 starts here, and it goes halfway around. The cosine is my x value, so cosine of 180 is negative 1. The sine of negative 90, sine of negative 90. So I start here, but I go this way. All right, I'm doing in blue. So I start here, and I go to here, that's negative 90. So sine of negative 90, sine is my y, is negative 1. Tangent of 270. All right, let's see where 270 is. So I'm always starting at here, 0, and I'm going 270 this direction, 90, 180, up 270 is right there. Okay, so tangent of 270. Well, tangent is sine, that's the y, negative 1, over cosine, which is 0. This is undefined. Doesn't work. Cosine of 0. Well, that's just 1, 0, and the cosine is the x. Tangent of negative 180. I got like so many colors going on here, so let's erase some of those colors. So tangent of negative 180. So I'm starting here, but I'm going this way, opposite way around the circle. So there I go, and I'm at the point negative 1, 0. And what is tangent going to be? It's going to be sine, which is 0, y over x. Well, that just equals 0. All right, and sine of 900. Yikes, how do I do this? So let's figure out how much past 360 this actually is. So if I do 90 minus 360 minus 360, because there's two sets of 360 that are in there, all right, I am left with 180. All right, so you just keep on subtracting however many 360s I can subtract from there. I can subtract 720, but I'm left with sine of 180. And what is the sine of 180? Well, sine of 180, here's 180 over here. Then the sine of 180 is 0. Right, so sine of 900 is 0. All right, since theta is an angle of rotation, the terminal side of theta can fall into any quadrant which will affect the signs. They might be positive, they might be negative, of the coordinates of x, y, which is also cosine theta, sine of theta, and therefore affect the signs of trig functions in the different quadrants. To help us remember where the trig functions are positive and negative, we use this acronym ASTC. So A is quadrant 1. In quadrant 1, all the trig functions are positive. S, in quadrant 2, the sign is positive. Now that means cosecant is also. In quadrant 3, the tangent is positive. That means cotangent is also. And in quadrant 4, cosine is positive. And that means secant is also. All right, so basically the way that we're going to remember this is ASTC. And you can remember it, all students take calc. All right, so all students take calc. A, let me get a red, all ASTC. So in quadrant 1, all the signs are positive. In quadrant 2, sine and cosecant are positive. In quadrant 3, tangent and cotangent are positive. In quadrant 4, cosine and secant are positive. All right, so let's practice that. State the quadrant theta must lie in if the sine of theta is greater than 0, so that means it's positive. So I'm saying sine is positive and cosine is negative. All right, well, sine is positive. Let me draw this. All students take calc. Sine is positive in the first and the second. Cosine is negative in the second and in the third, because it's positive in the first and the fourth. So second is where I'm going to have sine being positive and cosine being negative. All right. Tangent is less than 0, so tangent is negative. Well, that's true for the second and for the fourth, because tangent is positive in the first and the third. Sine is less than 0, so sine is negative in the third and the fourth. So what do they have in common? The fourth. Cosine is less than 0. So where is cosine negative? Cosine is negative in the second and the third. Tangent is positive. Well, tangent is positive in the first and the third. All students take calc. I'm looking at my picture right there. So what do they both have in common? 3. Okay, so in the third quadrant. All right, here we go. Unit circle. We're going to fill this in. So this diagram below represents the unit circle. We're going to fill in the ordered pairs at each of the following angles that are assumed to be drawn in standard position. All right, so 30 degrees. This is going to be 30. This is going to be 45. This is going to be 60. This is going to be 90. This is going to be 120. This is going to be 135. This is going to be 150. And this is going to be 180. This is going to be 210. This is going to be 225. This is going to be 240. This is going to be 270. This is going to be 300, 315, 330, and 0, or 360. So at 0, my point is 1, 0. Okay. At 30, remember it's cosine and sine. Cosine is my x, sine is my y. So cosine was radical 3 over 2, and sine was 1/2. At 45, cosine was radical 2 over 2, and so was sine. At 60, cosine was 1/2, and sine was radical 3 over 2. Okay, I'm taking this from the lesson from yesterday, these numbers. 90, well, this point right here is 0, 1. All right. Now, 120, how do I do 120? Remember, I have to think about a reference angle. The reference angle for 120 is 60, so it's actually going to be the same as 60. It's going to be 1/2 and radical 3 over 2, but I have to be concerned with where it's going to be positive and where it's going to be negative. Remember, this is all students take calc. So at 60 degrees, okay, or this is really negative 60 degrees, the cosine is going to be negative. The sine will be positive. Remember, cosine is your x. Maybe this will help if I write this. Cosine is your x and sine is your y. All right, so 135 is really just has a reference angle of 45. So it's going to be same as the 45s, but I'm going to have to pay attention to the signs because remember in the second quadrant, cosine is negative. 150 degrees has a reference angle of 30, so it's the same answers as the 30s, but in the second quadrant, cosine is negative. All right, so everybody can see like these numbers are the same. 30 and 150 are the same. These numbers, 45 and 135, are the same. It's just the signs that are changing. And these right here, 60 and 120. It's the same numbers, it's the signs that are changing depending on whether sine and cosine are positive or negative in that quadrant. Okay? 210 has a reference angle of 30. So again, it's going to have the same as the 30. Oops, I'll put that there. The same as the 30 degrees. My numbers are going to be radical 3 over 2 and 1/2. In the third quadrant, sine and cosine are negative, so they're both going to be negative. All right, and 330 is, whoops, I didn't mean to do that. I thought I had the highlighter. 330 is going to be the same as 30. So 30, 150, 210, and 330. All of those numbers have a reference angle of 30, so it's also going to be radical 3 over 2 and 1/2. In the fourth quadrant, cosine is positive and sine is negative. Remember, cosine is your x and sine is your y. All right, let's do the ones that have a reference angle of 45. So 45 and 135 and 225 and 315 all have the same reference angle of 45. So all of these are going to be radical 2 over 2. All I'm doing is going to be changing the signs. In the fourth quadrant, cosine is positive, sine is negative. Sine is my y. In the third quadrant, they're both negative, sine and cosine. So x is negative and the y is negative. All right, and the last ones that I'm doing are all the ones that have a reference angle of 60. So 60, 120, 240, and 300. Let's highlight those. Oops, I forgot to highlight the other ones in green. Let me go back and do that. All right, so 30, what is going on with the 30? Well, 30 is, not 30, sorry. 60 is 1/2 and radical 3 over 2. Remember, in the fourth quadrant, cosine's positive, but sine's negative. Same thing, 1/2 and radical 3 over 2. In the third quadrant, they're both negative. Okay, so as long as you memorize the 30, the 45, and the 60, then you're all set, because all of those are just have a reference angle of 30, 45, and 60. Okay, and then you just have to worry about the signs. And I have down here below also a picture of my 45, 45, 90 and my 30, 60, 90 if we wanted to get any of those values that we had. All right, and then the only one I need to fill in is 270. Well, the point right here is 0, -1. Okay. All right, let's see what we got. Regions question. So in the diagram below, the length of which line segment is equal to the exact value of cosine of theta? All right, so this is ST right here. This is ST, and this right here is OS, and this has a radius of 1. So cosine of theta, cosine is adjacent over hypotenuse. And the adjacent is that OS. And the hypotenuse is 1. So there we go. All right, so that's a regions questions. Number 6, there are many points on the unit circle besides the ones that we determined in this lesson. Every point, although, must satisfy the equation x squared plus y squared equals 1. So the unit circle has a radius of 1. Find all possible values for the y-coordinate for a point on the unit circle if x equals 3/5. All right, so there's two different ways to do this. Here's my triangle, okay? If x is 3/5, all right, my x is right here. I want the x value, so this is going to be 3 and this is going to be 5. All right, because the x, the left-right, is 3/5, so x equals 3/5. I find all possible values for the y-coordinate for a point on the unit circle if x is 3/5. All right, so the y-coordinate is going to be 4/5. Now, another way to do that is, watch, this might be a little bit easier. Maybe I should have done this way first. X squared plus y squared equals 1. X is 3/5. Well, 3/5 is 9 over 25. So now I'm solving for y. So I'm going to have y squared equals 1 minus 9 over 25. Well, in order to subtract, I need the same denominator. So I'm going to write 1 as 25 over 25. Whoops. There we go. 25 over 25. And 25 over 25 minus 9 over 25 is 16 over 25. So if y squared equals 16 over 25, then y equals 4/5, just like we had before. Okay? An angle theta has a terminal ray that falls in the second quadrant. All right, so the terminal ray falls over here. So I'm going to draw my right triangle over here. And there's my angle theta. It has a terminal ray that falls in the second quadrant. If it is known that the sine of theta equals 3/5, well, sine is opposite over hypotenuse, so I can put my 3 there and my 5 there, determine the value of cosine of theta. Well, this has to be a 3, 4, 5 triangle. You can use Pythagorean theorem, but to find that missing side, that's one of the Pythagorean triples. So therefore, the cosine of theta is 4/5. But remember, I'm in the second quadrant. In the second quadrant, cosine is negative. So this is going to be negative 4/5. Okay? And this last problem. Circle O has a radius of 2. An angle with a measure of 30 is in standard position. All right, so standard position means it's right here. All right, I got an angle of 30. So in a 30-degree right triangle, remember the side across from the 30 is 1, the hypotenuse is 2, and the side across from the 60 is radical 3. Or you could use Pythagorean theorem, but that's something that we're going to be using it so much, hopefully you'll have it memorized. If the terminal side of the angle intersects the circle at point B, what are the coordinates of B? So the coordinates of B are x, y, radical 3, comma 1. All right, there's a lot that we did today, so we'll be practicing all that tomorrow.